basic details from the foundation of the quantum computer. So I will start now basic, details about the quantum computer. It will be go through the introduction and history. What is quantum computer? Data presentation, operations on data, digital versus computer, and quantum computer comes and ends with Shor's algorithm, which was already used. So we'll begin with the foundation. First, we'll learn the understand about the quantum physics, because it is based on quantum physics. Quantum physics, quantum computer based on quantum physics, unlike everyday computers that you can code without knowing how they work. Computers, I can say QC is a quantum computer. QC are programmed using the principle of quantum physics. You need to know the basic quantum physics. It is not new. It is earlier. The study started in late 19th century, and it is going on. Most of properties of quantum physics can only be studied in the physics lab. But there is one property of the polarization of light that can be experienced using availability of equipments. We will study quantum physics through the property of polarization of light. Furthermore, photons, light's behavior exactly like quantum bits or qubit. I am repeating these words because these are the base of your qubit, circuits, gates, and everything. Quantum bits or qubits. So what you learn here can be directly used controlling the qubit or quantum computer. We'll study complex numbers, linear algebra, probabilities, and logic. I will repeat it again because all works on the mathematics of algebra and probability. I can say we work on what? 0 and 1. There is no probability. Only you can select 0 or 1 in binary. But there is a possibility of probability, and that gives the foundation of quantum computer. Instead of quantum programs, a structured circuit that operates on quantum bits or qubits. We'll learn how quantum circuits operate, how we can use them, perform computations. Popular tools are programming, debugging. Microsoft developed QHash. IBM developed QSkit. Require knowledge of programming language like Python. We all are using now Python. The same language is used here to perform the quantum computer programs and algorithm. The most famous algorithm quantum computing is Shor's algorithm. Now we can see here at present only two basic directions on the intersection of modern physics, computer science. That is material science. The first is a traditional approach, struggling to squeeze the more devices on computer chips. We know that capacity is overrated. So supercomputer is there, data science, data centers are there. Now, cloud technology is there. You can increase hardware, but there is again limitations on the get the data or hardware. This direction of central focus on nanotechnology, a modern science which uses nanometer scale 10 raised to -9 m to measure the size of electronic device from the intersection of computer science and modern physics. The field of quantum computer was initiated by the work of Yuri Manin 1980, as I said, Richard Feynman in 1982, and Dash in 1985. Which may be the applications used? The last session, sir already explained. This is not used currently in day-to-day operations or not in our regular programming or somewhere. This is an innovation where we required a huge computation. It can be in drug discovery. As you know, when we are seeing in lockdown period, Corona, the vaccine was not ready and it was taking time because of the many simultaneous parallel developments are going on. At the same time, it may be required material as well. What material, molecules can be divided, it is useful or not. So it again required parallel computing, or it may require a huge database supposed to be processed and drugs can be identified. So these are the some applications. Drug discovery is there, material science is there, artificial intelligence is there, financial modeling. We can use quantum computer to develop more accurate financial models. Also, it can be give you exact climate change in a Earth. So we can see detail how it will be useful for the drug discovery. The challenges. First, we'll understand the concept of application. Quantum computer hold immense potential of emerging drug discovery. Here is a deeper dive. You can see drug. What may be the challenge? Drug development often involves understanding how molecules interact because it is based on molecules. Can you just hold for a second?
Sure, sir.
So this,
You can hold.
sorry. So this requires simulating complex chemical reaction, which are computational intensive for classical computers, even for relatively small molecules. Quantum advantages, how it will overcome on that. Quantum computers with their unique properties like superposition or entanglement. You learn in the last session superposition, entanglement. We are going in deeper how exactly bit and qubit can be converted into superposition, how the advantage of superposition and entanglement can be potentially simulated. That can be on hardware side, that can be on qubit, but that is going to help the simulation of the drugs. What are the advantages? Faster and more accurate prediction of the drug target binding can be more understanding how drug molecules interact with its target. Protein thus crucial for the effectiveness. Quantum simulation would provide insight into the binding, the strength, and potential inside or side effects. Improved design of the new drug candidate. By simulating molecular behavior, researchers can design a molecule with optimized properties, such as higher proteins, better selectivity, and reduced toxicity. This all can be done by using this quantum computer chips or computers. So these are the high-end softwares, applications, or innovatives can be worked on and can be the research done on the different applications by using hardware as well. Now I can give you another example of solar system. Everywhere the government and all the technologies are promoting the solar, where we can use the material as well. We want to identify a better material which can be cost effective, which can be performance, higher accuracy or higher productivity. This can be simulated by using quantum computer and can be produce a better solution in this specific area. I hope you are clear with the application. Am I right? Hello.
Sir.
So
hello.
All are there. Am I right?
Yes. All are here.
So we'll go in a definition of quantum computer. Quantum computer is a machine that performs calculation based on laws of quantum machines, which is behavior of particles at the subatomic level, which uses quantum mechanical phenomena such as superposition and entanglement to perform operations on the data. Quantum entanglement is a physical phenomena that occurs when pairs or groups of particles are interact in the way such that the quantum state of each particle cannot be described independently. As we are going to see, but I will just explain, when a pair in a bit truth table There may be possibility that some of members may not be having electronics background, but I hope all are knowing the truth tables: 0, 1, 0, 0, 0, 1, 1, 0, 1, 1. So these are the pairs. When there is a 0, if you're using AND gate, NAND gate, or OR gate, exclusive OR gate, there may be fixed results are there. But we'll see how quantum computer will take advantage of the superposition. We are going to see in a detail. Another definition we can say, a computer that uses law of quantum computer machines to perform massively parallel computing through the superposition, entanglement, and decoherence, where classical computers that uses voltage flowing through circuits and gates which can be controlled, manipulated entirely by the classical machines. In digital computer, information is coded as a string of bits where each bit is in one or two definition. As we already discussed, 0 or 1. In classical computer, we have only on or off. In quantum computer, the elements that carry the informations are quantum states or quantum bits, that is called as qubit. A qubit can have value 0, 1 or superposition of both. I will repeat this. A qubit can have value 0, 1 or superposition of both, not a single. Again, it is called as entanglement. This slide is representing evaluation of quantum theory, quantum technology. It started in 1929, the foundation. It was evaluated. Further, the Shor's algorithm is evaluated in 1994. The innovations was happening in 1998. You can see first working 2-qubit quantum computer demonstrated. That was Grover's database search algorithm was developed. The innovations are going on. And now the commercial applications are available for certain big companies like Google claims that have reached quantum supremacy for the first time in 2019. There are more innovations are happening and we can see a more better computers and better positions, supercomputers, better supercomputer or quantum computer available for the advanced research and technology. These are some advantages where I can highlight faster processing speed, data storage capacity. So I think in earlier session, there was some questions, data storage and other things. So what is the advantages of computers, quantum computing? Faster processing and speed. Enhance data storage capacity. It will improve the data storage because of optimize, improved optimize and simulation. The third one, enhance cryptography security. As we are aware of that, there is a concept of blockchain. The security is very important and we need to have a better security to protect our data or application. So with quantum computer, we can have cryptographic security advanced with a better, because we are going to increase the hardware capacity, the different probabilities we are going to use, there should be cryptographic security provided, and that can be advantage of quantum computer. And last, I can say revolutionary machine learning and artificial intelligence as well. Because when we talk about revolutionary machine learning, artificial intelligence, it works on huge data. Now the industry computer, you maybe learn, we started near in 1960. Now we can say near around 40 60 years, data is very huge. All companies are working on data intelligence. Different algorithms are ready. They have to use that algorithms and produce exact result for customer, maybe vendors, maybe profitability or financial, which can be very easy and faster decision making in the real life application of commercial industries as well. Now we can come to the basic of representation and basic concept of the uh, bits and qubit. The representation of the data qubit, the idea of bit is different. Bits are not merely on or off. They can be in the superposition. Bits are not independent of each other. They can be entangled. So what exactly happens here? Quantum computer builds upon the weird behavior of quantum physics. Don't worry. It is very easy concept. Only it is a polarization concept is used to understand and get the exactly the data to capture apart from on or off. The notation of bit is different in quantum computing. In quantum, bit is not, as we said, on or off. It can be superposition. Bits are not independent of each other. They can be entangled. There is a fundamental difference in the way of program quantum computer. It is not based on the one neon architecture. One neon architecture is nothing but it was working on binary data. But like a CPU is what we use in our computer. But it is performed, the CPU plus memory is a model, doesn't apply in quantum computer. Quantum computers are designed like digital circuit with gates instead of bits. It works on gates, not on bits. So we have to have new gates innovated for quantum computer. We are going to see in our next session in detail. The bits are not, qubits are not independent. They can be superposition and entangle with each other. Superposition entangle required us rethink algorithm and fundamental way. So you can see in this presentation on the screen. Are you able to see the screen? Hello?
Yes,
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 sir.
yes,
Yes, sir.
sir. Yes.
The
Yes, sir.
presentation of qubit. You can see here a bit of data is presented by single atom that is in one of the two states denoted by a 0 that is called as gate notation. It is called as ground state. That is gate notation. It is called as gate. You can see. Hello. So 0 and 1. So 0 represent that a ground state. And the 1 position that is called as excited state. A single bit of form known as qubit. The physics implement of qubit could be used to energy levels of the atom. An excited state presents superposition, that is excited state, and a ground state of the representation. So you can see in the next slide. Please remember this, that is a ground state and excited state. When atom is moving in a sphere, it can be in a ground state or it can immediately move to the excited state. So we'll see in the next stage, next slide. A single qubit can be forced in the superposition of the two states denoted by the addition of the state vectors. You can see here a symbol is called as psi, a silent p and psi. Alpha 1, you can see ground level, alpha 2 of the excited state where alpha 1 raised to 2 complex numbers alpha raised to 2 plus is going to be 1. In truth table, we can see more in detail how exactly a NAND gate or any OR gate is working. This is a representation of superposition. You can see here, it is a ground state. At the same time, when you can see here state as excited, When ground state and 1 is excited state, then we can see here is a superposition. In normal bit situation, we cannot have this position because there is a output 0 or 1. We can't capture the position of superposition, which exactly we can get into the qubit. And that is the advantage of quantum computer. So 1 qubit, mathematical abstraction, vector in 2-dimension complex vector space. Tricks notation, you can see here, when we talk about sphere, it can rotate around a vector. It can be column vector or a row vector. It is called as CNOT or BRA. BRA dual vector transport the complex conject realization of qubit. Nuclear spin, positive, negative, polarization of photon, left or right, electron state, ground or excited. I hope you are understanding what I want to pass the information. A bit versus a qubit. A bit can be two distinct states. We already studied this. There is a repetition many times to understand and make fundamental clearance. Can be in two distinct, 0 or 1. Measurement does not affect the state. If you combine the both, it is not going to affect the result. But in qubit, can be in a state of ground level, that is ground state, or instead of excited, or any other state that is a linear combination of basic state. So when we measure the qubit, we find it if it is in state of ground or 1, the exactly output will get the opposite. 0 can be because it is a superposition. So we can get a 0, 1 or 1 into the 0. So this can be a graphical representation where we can say superposition of state. Different qubit molecular is moving in a sphere. There is a ground state and there is a 1 excited state in 1 qubit. Can be converted P0 or P1. When it is a P0, you can see a 0 or it is a 1. So this is how exactly the molecular is working or moving into the physics technology as a superposition. So in general, quantum computer with a qubit can be an arbitrary superposition of 2 raised to n. In earlier session, sir explained that in bits there is a multiplication, but here we can see that is to raised to n. So say when we say it is a 1 byte, it can be only 2. But when it goes to a qubit, 2 raised to 2. So we may get 4 possible outputs. If we go for a 3, we can get a 8. Exactly raised to 4. If we get in normal, 8 possibilities in bits, but exactly in qubit it may be 16. That is the advantage of quantum computer. Qubit represent atom, icons, photons, electrons, and their representatives control device that working together to a computer memory and processor. If we attempt to retrieve the values presented within a superposition, the superpositions randomly collapse because it is moving, it is not fixed. This may collapse, but the value which is captured is remains there as it is. So that is the advantage of quantum computer. We can understand here entanglement. Entanglement is the ability of quantum system to exhibit correlation between states within the superposition. We have seen earlier diagram when 0 and 1 are correlation can give output of 1. The entanglement pair is a single quantum system in a superposition of equally possible state. The entangled state that contains no information about the individual particles, only that they are opposite side states. Imagine two qubits, each in a state, sorry, each in a state as a ground level or one, a superposition of 0, 1, we can entangle the two qubits such that the measurement of one qubit is always correlated to the measurement of other qubit. So here are the difference. I'm trying to cover all the basic questions in your mind that may be classical bits and quantum computer. Can be in two distinct states, 0, 1. In quantum computer, can be in a state as a ground or in a state 1 or in other state that is linear combination of two states. Is that clear?
Yes, sir.
Hello.
Yes, yes, yes,
Yes,
sir.
sir.
Yes, sir.
The next is can be measured completely in a
That's what I'm saying. In classical computation, we use the term X when we are not sure it is a 1 or a 0. So what is the difference between that X and this third state where you're saying it can either be a 1 or a 0 or an intermediate state? So how do we take it?
So I will explain it
In our
because you
computing.
can see the physical the truth table, then you can understand that.
Mhm.
When you say X, that is not captured as an output. Am I right?
No, X is, it can either be a 1 or a 0. It's not definite,
But the
indefinite.
output is not captured because with that.
Yeah,
When you use in electronics
yeah.
or bits, the output is not captured 0 onward combination. The 1 or 0.
Determinant state, we call it.
Yeah, we'll discuss that later. So can be measured completely. In quantum bits can be measured partially with given probability. This probability is important because probability is not there in classical computer. The third one is are not changed by the measurement. There is no change. As I was discussing with Madam answer, I was trying to answer. There is no change in output of, depending upon when we use 0, 1 truth table or something like, are changed by the measurement. Can be copied in classical, cannot be copied. The next is can be erased. You cannot erase that because it is in superposition, which is captured in a quantum computer. The next slide, we can see the features. Unit of information is bit. Quantum computer, it is qubit. State is 0, 1. In quantum computer, superposition of 0 and 1. Processing in classical computer is a sequential. In quantum computer, it is a parallel. In complexity is limited. In quantum computer, it is exponential. You can't control that. You can have a good capacity in processing, in storage, in all way. Current application, wide ranging in classical, here in quantum computer, emerging with the potential of significant impact. So I can say one more thing in detail. In classical computer, the smallest piece of information are on something called as bits. Each bit can have value either 1 or 0. With 1 bit, there can be 2 values possible. With 2 bit, the values can be 4, as I earlier said. When we say 2 bit, it is a 4 value. When 3, 6 values and so on. The quantum computer uses the principle of quantum entanglement, quantum superposition. The quantum superposition is subatomic particle is said to be all possible state at the same time. Only when it observed does it again itself particular values. In quantum entanglement, the particles are entangled. That is, one particle is observed, it takes a specific value. It can be entangled pair takes the opposite value of the same instance, irrespective of how far they are. That doesn't matter. It is a physics. So quantum computer, instead of bits, they are qubit, that is a quantum bits. While bit take either 0, 1, 8 value, qubit take 1, both 1 or 0 as its values. With 1 qubit, values are 2. With 2, 4 is a exponential. And we can store more and more data into this. So this is a representation of our classical data. The basic unit is in classical data is binary digit called as bit that can take on the value of 0, 1. In classical computing, we can represent datum by storing the bits. A beta A may be written in 0, 1, 0, 0. This is the bit return value. Number of 137 can be written 100, 1001. So this happens in a typical classical computers. When we are coming to the Boolean variables, because it's a bit base value. I hope all are clear with this logical operator and operator, because this is the base of bits and classical computers. These operators and or not have very precise meaning. The precise meaning enables symbolic manipulation of the expression. As you see here in a red mark, A and B or C. What it indicate? It can be A and B or A and C. Evaluation sequence may be not and or. The parenthesis also makes important role to evaluate the bits value when we work on a bits. How we work on this? Similarly, Boolean or algebra evaluation sequence. All the logical operators, multiplication or parenthesis can be applied here. Then only we'll get the output. This is a base of classical computer. Am I right? Consider another example. A or B and C or we can see here. It is very complex to understand how it is going to work on this. We can see when evaluating Boolean expression, you can treat and like multiplication or like addition. Am I right? The rules of NOT are little tricky here because we can see here NOT is not used, but we can add NOT as well. And is like multiplication or is like addition. So it can be changed into the same expression. We can explore A and C or A and D or entire B and C. So this is a Boolean expressions we are working logically. For better understanding, I have given these examples. These are the gates we can see here. Logical gates on which we are working as a classic computers. It is starting with a AND gate, A and B. The next gate is OR gate. The output of A and B is one input for OR gate. Am I right? And the other input is a C for OR gate. And on top of that, NAND is there. So not A, not parenthesis in a bracket, A and B or C is a logical circuit created for the classical computer. One more example we can see here. For better understanding how logical classical computers are working, we can have a logic gates. Two here. One is again, this is a AND output. but inputs are three inputs. Three gates are there: A, B, C for the AND gate, D and E for AND gate. One is NOT gate. So A, B, C. If all these true are there, then only this output is 1. D and E is both are 1, then only we'll get output. And whatever value we are providing F, opposite of that can be input to the OR gate and output will be the G. So here we can see G, A and B and C, or D and E, or not F. That is the output of these gates. Is this clear? This is the concept of our classical computer. Now we are moving, before going further, I want to highlight probability concept. So just to get comfort, a typical our day-to-day operation example I just thought. If I want to buy a house in a specified area in Pune, in Maharashtra, maybe many people are from different state. I can give example of Hinjawadi area, which is located nearby IT sector, and I want to look for the house. So what may be the possibility? House hunting and quantum polarization involve a superposition of possibility. I want to give you a concept of probability and yes, no. So possibility process of measurement collapse the superposition and probabilistic outcomes. This analogy helps illustrate how the principle of quantum machines such as superposition and the probabilistic nature of the measurement can applied understand real world decision making process even in apparently unrelated contexts like house hunting. So scenario is that I am purchasing, I want to buy a house in a IT area near Hinjawadi. What may be the basic criteria? Imagine you are searching for a house. Your idea home is specific set to polarization. What is the polarization concept here? Quiet neighborhood, large playground. This may be the parameter which may polarize me to buy a house. Close to good school, and the important is affordable price. These are the different parameters I am looking for. They are going to polarize me. Am I right? So finding right house, superposition may be one thing, measurement, house being, how it will work. When we come to the quantum thought, superposition, you have set of potential houses, each with combination of polarization, quiet playground, good school, affordable. Measurement, what may be the measurement? You visit the house, evaluate their features, quietness, playground size, proximity of school, and access their affordability based on your budget. These may be the measurement you applied on that. Probabilistic outcome is house that perfectly matches all your desired polarization, quiet, large playground, good school nearby, and affordable, has the highest probability of being chosen. So these are the points which may polarize. A similar can be concept applied into the hardware evaluation and can be applied into the supercomputers like what we are studying. So these are the polarization probability, house hunting, quantum polarization. In details are there. I will just explain you one superposition. What is different? You initially consider a set of house, each with combination of desirable features, as we discussed, quite near neighborhood, large playground, good school, affordability. This analogy of photon being superposition of polarization state, it excites in a combination of possible polarization, that is horizontal vertical dynamism. When we think about quantum polarization, a photon can excite superposition of multiple polarization state until it measured one. all combination when we consider, say for example, quiet neighbors are good, school is maybe little longer, but in my budget, that may be the polarization and can be the output of my superposition. Is that clear?
Yes, sir.
I hope you are understanding. I want to link the superposition, polarization, and the thought related to give a thought of the polarization concept. We'll see the probability because the major difference which I understood in classical computer and quantum computer is a probability. A Boolean algebra works with the events about which we have definite knowledge. Definite knowledge is nothing but output is predefined, 0 or 1, simple way. I'm repeating it again. The stage on or off for event that is already happened. We know that corresponding Boolean statements can only true or false. We had defined knowledge about events in the past. And output is fixed. Both are 1, 1, then we'll get 1. If 0, 1, we'll get 0. If 0, 0, it will give 0. Similar to that. So Boolean algebra is equivalent to the exactly the output which are known. There is no maybe, there is no perhaps, there is no probability. Our knowledge is assumed to be complete, defined, but what about events that haven't yet happened? The future is uncertain. Boolean statement might either true or false. We don't know certain which is it will be to the future uncertainty. And that exactly we capture into the uncertain events in the probability. An event A might not occur in future, but we often know likely A occur and conversely how likely A not to occur. So events whose outcome cannot be predicted with certainty, the quantum theory, we doesn't directly talk about the physical properties of the system like location, momentum, and so on. Instead, we talk about probability, distribution of each of these physical properties. Probability gives us tool to predict outcome of the event that are uncertain. Uncertainty based because of insufficient information, poorly understood the mechanism, inherently matter of chance, quantum physics. We cannot predict the outcome. Instead, we can predict likelihood of each possible outcome. Maybe is a probability. True probability is a perfect balanced coin. I can give you here example from the physics, probability of head and probability of tail. If we throw coin in air, that is a half 0.5. Estimated probability, financial market, unknown mechanism, insufficient information, experience. The similar example, we can throw a die. Instead, when we roll a dice, there are 6 probably possible outcomes. We can't predict the outcome with certainty. Instead, we can predict the likelihood. It may be, 1, 2, 3, or any of the 6. So probability is 1 of 6. But if I throw 2 dice at a time, there may be probability of coming 2 different, or it can be a multiple outputs, right? Sometimes we can obtain a true likelihood uncertain outcome. Suppose we have a coin. We can run physical test of determine the destiny, distribution of material of the coin, its balance or other attributes. If we find through physical test that the coin is perfectly balanced, then we can know the head or tail is equally exactly likely. So probability works with the events likelihood that some events occurs. As we have seen, probability of coin is a half. In other situation, we can't model the outcome with the physics. Financial market outcomes are driven by the behavior, unpredictable human. There is no way to model the behavior of humans with the maths. In such cases, we can experiment, collect the data about the actual historical outcomes. We can use AI, machine learning here. The data helps estimate the probability of future events. In this slide, we can see probability is about the predicting likelihood. Will sometime happens or not? How likely is it to happen? How unlikely? Which most likely outcome? The idea of event can be linked to Boolean logic. The Boolean statements being true is event that might occur or not occur. So we can talk about the probability of the Boolean statement. Just remember that there is, when we apply probability of techniques of Boolean statement, we are actually talking about probability of the Boolean statement can be true or false. So see here, probability can be explained is a 0, P in a bracket. Probability of event A is a P, parenthesis A. Probability of occurrence of both event A and B can be in P, A and B. We are comfortable with this. Probability of either A or B is P into the bracket or parenthesis. We can say P, A or B. Mutually exclusive events, we can see. This is a basic concept of probability. Event A and B are mutually exclusive. What it indicates mutually exclusive? If A occurs, then B does not occur. And if B occurs, then A does not occur. Alice owns only one car and it is a red color. Alice owns only one car, it is a blue. This is not possible that Alice is having one car and that may be red or blue. If Alice is having two cars, then there may be possibility that it may be either one car is red, one car is blue. So what may be the probability of that? Alice owns only one car and it is red. Alice owns only one car, it is not red, is a probability. Please understand this. Alice owns more than one car. Alice does not own any car. There is no person named Alice. So when we talk about the probability, there may be 5 different statements which is not possible check in classical computers, but can be studied by using quantum computer logic. Probability of complete set of mutual exclusive event add up to 1. When we say that there is a two different things come in, probability of superposition or something like that, then definitely we can talk about the supercomputer or quantum computer. Events that are unrelated, independent events. Alice owns a red car, Bob's owns a blue car. These are independent. There is no link between these two. If Alice and Bob didn't plan together and choose a color of their car, then these events are independent. They are buying the car independently, the color may be. There may be possibility that by chance or by luck, the car color may be same. That is another probability we can see. Now we can see here manipulating probabilities with algebra. P Boolean expression, P this, how it works. We can explore that A and B or not C or not D. Okay, algebra of probability. Simply, P is a Boolean expression in terms of P of A, P of B, P of C, and all the detailed expression can be studied. Mutually exclusive, A not equal to B, B is not A and B cannot occur simultaneously. P, A and B, P an event that cannot be occur zero. It may not be zero. When A and B are mutually exclusive, P, A and B equal to zero. We'll come to the detail of qubit to understand this. So bits, possible values. Now we are combining two different possibilities. Bits in a computer memory can be 0, 1, right? A bit being a 1 is an event that can be analyzed through the probability theory. In quantum computing, we will analyze the probability quantum bit. There is a situation where we know the probability of groups of bits taking certain values, and from that we need to find the probability of individual. In this situation, on the slide you can see 0, 0, 0, 1, 1, 0, 1, 1. The possibility of combination 2 bits are shown here, right? We call it is as a bit. The first bit and the bit right, each combination can be considered as an event. The event first is 0 and second bit is a 0. Similar to that, 0 and 1, 1 and 0. This is an event. The event both bit is 1, 1 is the last. There is a complete set of mutual exclusive event. They are not dependent, they are mutually exclusive. Exactly one of these events 0, 1, 0, 0, 0, 1, 1, 0 or 1, 1 is always true, right? Now we can see more. Let's find the probability. What may be the probability? The first bit is 1, the second bit is 1, or first bit is 1 and second bit is 0. P 1, 1 or 1, 0. Okay, the first bit is 1 and second bit is 1, or first bit is 1 and not second bit 1. That is a 0. We are converting that. Not 1 is a 0. This is a form A and B or A and not B, which simplifies A, that is a P of first bit 1. So this way we can give a thought of Boolean and how the logical can be done in qubit. The first bit is 1 equal to P 0 1 or 1 1 equal to P of 1 0 plus P of 1 1. Similarly, a P second byte of 1 equal to P 0 1, P 1 1, P first 0, P 0 0 plus P 0 1, the second byte 0, P 0 1, P 0 0. So this is a similarity of the, or we can say between for classical gates and circuits. You can understand here, quantum logic gates are basic building blocks of quantum computing, which is a field that explore the use of quantum mechanical phenomena to perform computational tasks. The key difference between classical and quantum logic gate is that the classical gate operates on bits that have a binary value of the either 0, 1, while quantum gates operate qubit, which are fundamentally unit of quantum information that can exist in superposition of both 0 and 1. A quantum gate can be manipulated and exploit entanglement of qubit, which is quantum mechanical phenomena, where the state of one byte depend on the state of other. I will explain this when the table or gate you can see, and you will easily understand that. We define a classical algorithm to be any sequence of such a classical operator, usually to do something useful. A classical computer is any device that implement a classical algorithm. Although modern classical computers depends on quantum machine, the algorithms they are implement to do. We could be principal design a classical computer that does not depend on the quantum machine. We can see more on a qubit as a two-state system. Or quantum gates, quantum register, and entanglement. I can repeat, we have already seen this. A quantum bit qubit is a two-level quantum system. We can label the state as a ground level, that is presented hyphen, sorry, slash, we can say is a Kate notation ground state, and the other is a Kate notation excited, first excited. The principle, this could be any two-level system. The 0, 1 represent Kate notation from ground state quantum system, and this 1 represent the Kate notation for first excited state of the quantum system. Unlike classical bit, which is definitely in the either state, the state of qubit is in general mix of 0, that is a ground, or excited. So this pi, we can say C0 is a ground level, C1 is a combination of this. We assume that normalized state is a C0 square, C01. The output when it is 0, it superposition will get the output as a 1. This pi we can pronounce represent the Kate notation for wave function of the quantum system, standard notation of quantum machine called as Dirac notation. For convenience, you can easily understand the convenience we can use the matrix representation when we say 0 as a ground, 1 or 0. Output of this is a 1. And when it is a 1, 0 and 1, we'll get by using NAND gate or AND gate, we can get the output. Here you can easily understand the sphere. The quantum logic gate is an operation that we perform on one or more qubit that yields another set of qubit. You can see here polarization. This is a ground, 0 state on the top Z axis. 1 is on the X axis and Y is here. So when the polarization happens, the state of Z or X axis, it will ground, it will immediately change and reach to the excited state. And at the same time, we can have addition of both. So we'll get 0 plus 1 and square. The output of the state will get the 1. Quantum gate is transformation from one qubit state to another. Single qubit gate rotation around Gauss sphere reversible, represented by unitary matrix action on the vector. So these are the different gates used to analyze or use in quantum computer. One is Pauli X, where the matrix represent 0, 1, 1, 0. If you go, if you see on the row side, Pauli Y, that is a 0, minus I, 0, Pauli X, that is 1, 0, 0, 0, minus 1. Hadamard gate, we can use 1 upon square root of 2, that is 1, 1, 1 hyphen. These are the different gates used to develop a quantum computer as a hardware and use in different quantum computers. We'll see either 1 or 2 gates in a detail, not all, but these are different gates used in a quantum computer. Similar to gates, but different matrix and output may be controlled by the different gate controlling power will give the output. Now in a classical computer, you can see computing the NOT gate returns 0 if the input is 1 and 1 if the input is 0. The matrix represents as a 0 1 and 1 0. This happens in a classical computer. Here you can say Pauli X gate. This gate is synonymous with the classical reversible NOT gate. Matrix represent as X, U0, 0 1 and 1 0. U0, this is a ground level excited. You can see here matrix 0 1 1 0, and the matrix we are using here another in the parenthesis 1 0. If you multiply that, the output is 0 1 and the end output is 1. If not 1, you can exactly opposite, will get the output as a 0. So in a table you can see input is a ground state, output is as a superposition or excited with a combination that is a 0. 0 is converted into 1, 1 is converted into 0, and alpha 0 plus beta 1, that may be alpha 1. Combination of both. Here you can see Pauli X in detail. Excited output 0, output is 1, 1, 2, alpha 0, and combination of alpha and beta that gives us output. That is a 1 or 2. So superposition and ground reality, excited and ground, can be converted because sphere is moving. It is there for a certain period and we have to capture that value, can be calculated for the quantum computer. This is another gate you can see. Hadamard, wash. A useful gate classical computer has more 1 bit likely, while quantum computer will probably consist of multiple gates as well. I'm just moving ahead and showing you the truth table, how exactly it is going to work. So in quantum mechanism, it sometimes occurs the measurement one particular particle with the effect of state of another particle. Even though classical there is no direct interaction, this controversial interpretation, when this happens, the state of two particles said as an entanglement. Operations on data, setting the qubits in a control initial state that represent the input. Then they are manipulated with the fixed sequence of quantum logic gates. The sequence of gates to be applied is called as quantum algorithm. This is a difference between classical and quantum computer. We can have a variety of algorithm in classical, but in a quantum computer, we can see sequence of gates to be applied is called as quantum algorithm. Calculations end with the measurement, a collapsing of system qubit into one of the 2 raised to n pure state where each qubit is 0 or 1. So you can see here, this is a gate representation. Due to the nature of computer physics, the distortion of the information is a gate will cause the heat or to be evolved, which can be destroyed. You can see in normal gate 0 0, when output is 1, then only 1 1 1 is there. But all other 0 0 0 1 1 0 output is a 0. Okay. In quantum gate, similar to the classical gate, but do not have degenerate output. There is original input state can be derived, their output state uniquely. They must be reversible. This means that the deterministic computation can be performed on the quantum computer only if it is reversible. Luckily, it has been shown that the deterministic computation can be made reversible. See now, in this gate, Hadamard gate, simplest gate involves one qubit and is called as Hadamard gate, also known as square root of NOT gate, used to put qubit into the superposition. How it will work, we'll see here. So this will clear the gates circuits and how exactly control gate which operates on 2 qubit is called as control gate. Control NOT gate, CN gate. If the bit on the control line is 1, this is a control line. Okay. The normal gate representation is there. 0, 0, output is 0, 1. Okay. 0, 1, 1, 1. Because 0, it gives the output 1. Output A, 0, change the 1. 1 and 0, output is 1 and B is a 0. 1, 1, it changed to 0 and 1. So whenever there is on the third row or second row, 0, output of A hash is a 1. The CN gate has similar behavior of XOR gate with the same extra information, make it reversible. So exactly in a detail, control qubit, the qubit determines whether NOT operation happens on the target qubit. Target qubit is this qubit is flipped from 0, that is ground level, it will change to the excited state, or vice versa. If it is excited, it can change to the ground level. If control qubit is in the state of 1, in the visual representation you can see here exclusive OR gate is there. Input is X and Y. 0, 0, 0, 1, 1, 0, 1, 1. You can see here output X is 0, 0, 1, 1. But how it will happen now? When you make Y plus X, the state of output is going to be changed when you use X and O. The output will be Y and Y plus X is going to be changed because of the excited state. We are using NOR gate here. 0, 1, it is a 1, 0. 1, it is going to change 1 and output is going to be changed here. If the control qubit is in the state 0 excited, the target qubit remains unchanged. Target, which is the target here? That is the output. Okay. If the control qubit is in state 0, the target qubit is flipped. The CNOT gate is reversible, meaning the operation can be undone. This crucial gate of creating entanglement between qubits. So this is another control A, B, C. You can see the output 0, 0, 0, 0. All are 8 combinations are there. As I said, if it is the difference between classical and quantum computer, it can be possible outputs are only 6 in classical. Here we can get 8 combinations are there. So we can see here the output. Here are the excited. B and C are 1, 1 and A is a 0. Can you see my mouse pointer? That is a yellow row. Are you there all?
Yes, we can see that. Thanks.
So
Yes.
0, these both are going to impact on my superposition and output will be 1. Exactly in a reverse, when B and C are 1, 1 and A is 1, the output will be changed as a 0. This value is going to be captured as a superposition or entanglement. And this is how it is working in a quantum computing. So these are some universal quantum computers. CCN gate has been shown. Universal reversible logic gate. More detail you can study and you can have understanding of better quantum computing. I'm trying to give you a basic concept. I tried more details on gates and how quantum computer works exactly with a different concept. This is all about from my end, because more details we can discuss. The concept of Shor's algorithm is also there, but I hope that can be covered in coming lectures. So I will not spend more time on that. Any questions or other doubts or clarification, we can discuss more.
So I was a little confused about the concept of reversible gates requirement. Why is it needed to have reversible gates, and what do you mean by heat is generated?
So when we talk about reversible gate, we discuss about superposition and entanglement. In normal gates, we don't capture that value. I will give you a simple example here. I will exactly on the screen. When we use the gate in a classical computers, the AND gate, if we say, or any gates we use, the position of polarization will not capture. Only the output is 0 or 1. But polarization position, when it is moving towards X or Y, it is entangled to the position of output, which is maybe close to 1 or maybe close to 0. That is the excited position of the atom, or excited or ground position of the atom. So we have to capture that, which is a similar concept of physics of the polarization is converted. The concept of polarization, light polarization, and can be captured the value, so it can be the physically the storage, and as a challenge of the bits are storing, or whatever chips are electronics position capturing the input and storage processing. We require more storage, more different state of the gates can be converted and can be stored and processed. That is why we require not exactly the polarized state we can capture. And with different logics only, we can develop the algorithm of quantum computer. It is not like classical.
No, I mean, I get that. The idea was reversible logic states only can be used as quantum gate states.
It is not reversible, but it is controlled. Here the concept of control logic gate, not reversible.
No, that is okay. A couple of slides behind that, there is a condition that what kind of gates can be used as quantum gates. So I think slide number 71 or 73. Yeah, here, 70. 70. And one more ahead, one ahead of that. Here it is, correct. So you have said in 70 and 71, there is the first sentence. There is some heat to be evolved. Like what kind of heat we are talking about? Why is the heat there?
This is a heat. Heat is nothing but for understanding. This is what I explained. 0, 0, output is a 0, right? And 0, 1, again we are getting 0. So value is a destroyed. To understand, heat is the output is a 0, destroyed. That is what the concept.
Right. I mean, this is what I was wondering is, do they mean in the information theory that entropy starts to get involved here? So if you don't preserve the information, then where does the information go? Because you need to conserve the entropy and the states available as conservation. Entropy usually increases.
So as I mentioned in a session, there is a possibility the state is going to be changed, but the value which is called is not vanished. We can capture that and can be performed or used for the storing or the processing. That is the advantage of quantum computing.
Sir, my doubt is, how do you polarize your electron or the quantum bit? How do you polarize it? In normal computing, you have 1, 0, you have logic levels, whether it is 3.3 volts
So,
or
so
5.
madam, here we are using different gate logics. As I shown you classical computer, there are, I mentioned in the algorithm. Algorithm is developed by using gates only, not a normal classical algorithm. So different, in details, there are different, what gates we are using here. I shown you some gates which are used. These are the different gates. Use of these gates are going to generate the algorithm, not the normal algorithm. The combination sequence of gates are going to capture the information. So it can be Pauli X, next is a Pauli Y, based on the phase SP or control gate, control Z, swap gate. These are going to generate the algorithm. That is the,
I think she's asking about polarization, mechanism of polarization, not gates. So I think what she probably means
mechanism
is
of
that
polarization
is
I
the
explain here. So the state of atom is changing its state immediately with the sphere. It may be close to ground state or may be excited. Next moment it can be changed, and that is the exactly the state we are going to capture in the quantum computer.
so I think what I may, if I may contribute, the way we change the atomic states in physical format is usually
Right.
through something called as a pi pulse of a laser or electromagnetic radiation, where pi meaning 180 degrees of spin flip. So as you know, polarization can interact with electrons' spin, and this atomic spin, if it is given a external axis, then an incoming photon of a particular wavelength, like if the wavelength is only half of wavelength, like pi by 2 or pi, then you have just sufficient interaction to oscillate the electron from plus one state or a plus half to a minus half. Now this is a vectoral change, and that's the Bloch sphere is trying to show you the full pi rotation in the theta direction. Now there is also another angle called the phi. Now phi rotation is amount of the amount of contribution of both the states if it is in between. So to answer your question is to change polarization. If it is light or if it is vector representing state of an electron, pi pulse could be used. If it's a superconducting qubit, then you have to use different timing circuits or interference circuits. So there are multiple ways to interact physically to change this particular block here, the vector.
Yeah, this is a more precise answer on the physics concept. The same concept can be used here and store into the truth table or it gets, I can say.
Thank you.
Okay, sir, thank you so much, sir. And any more questions from our participants here?
Madam, this PPT is, very knowledgeable, and I'm sure sir has taken very much efforts. Can we have this PPT, please, ma'am? Can we?
Yes,
Can
sir.
you?
Like we do have the
They have
recording.
promised to share all the recordings.
Yes, yes. We'll be sharing all the recordings, sir. Yes.
Thank you. This session was very knowledgeable. Thank you very much.
Ma'am, here there is a main gate format and that sites of execution, which we used any simulation to do this one.
So we can do because many I think are not studied in that detail. I will check and come back to you. But as in early session, AWS has given some labs are there. You can become a participant and definitely you can do there.
Okay, sir. Thank you.
And